Nominal interest rate. Here, the interest rate is quoted on an annual basis and does not consider compounding period into account. The interest is calculated only on the principal amount, just like that of simple interest. The nominal interest rate is the periodic interest rate times the number of periods per year. Effective interest rate. Here, interest rate is quoted more frequently than annual basis and compounding period into account. Compounding period may be daily, weekly, monthly, quarterly, or semi-annually. The interest is calculated on the compounded principal amount like that of compound interest. Relation between nominal and effective interest rate. IEFF is equal to 1 plus I nominal divided by m whole to the power of m minus 1, where IEFF is the effective interest rate, INOM is the nominal interest rate, m is the number of interest periods in a year. When the compounding period is semi-annually, m will be equal to 2. If the compounding period is quarterly, m will be equal to 4. If the compounding period is monthly, m will be 12. If the compounding period is weekly, m will be equal to 52. And if the compounding period is daily, m will be equal to 365. The effective interest rate on an annual basis is always greater than that of nominal interest rate. Both effective and nominal interest rate are equal only when the compounding period is a year.
Now we'll solve an example on effective interest rate. Determine the effective interest rate for a nominal annual rate of 8% that is compounded. We have 4 sub questions for this. If the nominal annual rate is compounded daily, what is the effective rate? If the nominal interest rate is compounded monthly, what will be the effective interest rate? If it is compounded quarterly, what will be the effective interest rate? And if it is semi-annually, what will be the effective interest rate? So this is a direct question. There's no need for any explanation for this. They have given you what is the nominal interest rate. You are supposed to calculate the effective interest rate. So we'll solve it. Solution. Given data. Nominal interest rate. Nominal interest rate or annual rate. I think it's fine. Annual rate, which is I nominal, is equal to 8%. Now we are supposed to determine effective interest rate. So effective interest rate, which is denoted as IEFF, is equal to, the equation for this is 1 plus I nominal divided by m whole to the power of m minus 1. So this is the equation to determine the effective interest rate. Now here the value of m is number of interest period within a year. So here they have given for the first question, we'll consider what is this value of m. Effective interest rate compounded daily. Effective interest rate compounded daily. What is the value of effective interest rate if it is compounded daily? So here the value of m will be equal to number of interest period within a year. So since it is compounded daily, so in a year it will be 365 days. So therefore the value of m if the nominal interest rate is compounded daily will be m is equal to 365. Therefore I effective will be calculating I effective. I'll be directly substituting the value to this particular equation. 1 plus I nominal is 8%, which I'm going to convert it into decimal, 0.08. 1 plus 0.08 divided by 365 whole to the power of 365 minus 1. So this gives us the value of effective interest rate. Okay, 1 plus 0.08 divided by 365 to the power of 365 equal to minus 1, which gives us an effective interest rate of 0.0833. So this is the effective interest rate if the nominal interest rate of 8% is compounded daily. 0.0833. If I convert this into percentage, it will be equal to 8.33%. Now, second part of the question, we are supposed to determine the effective interest rate if the nominal interest rate is compounded monthly. So this is not effective interest rate which is compounding monthly. It is the effective interest rate if nominal interest rate is compounded monthly. Similarly, effective interest rate if the nominal interest rate is compounded daily. Don't get confused with the notation. Now we'll calculate what is the value of m. So m is number of interest period within a year. So in 1 year you'll have 12 months. Therefore the value of m year will be 12. Now we'll calculate the effective interest rate. IEFF is equal to 1 plus 0.08 divided by 12 to the power of 12 minus 1. If you solve this equation, you're going to get the effective interest rate of 0.083. This is in decimal. If I convert it into percentage, it will be 8.3%. Now the third part, effective interest rate if the nominal interest rate is compounded quarterly. I will calculate the value of m. So quarterly, so we are going to divide the whole year into 4 parts. Therefore, the value of M for this will be 4. Now we'll calculate the effective interest rate IEFF, which is equal to 1 plus 0.08 divided by 4 whole to the power of 4 minus 1. So if you solve this, you're going to get the value of I effective to be equal to 0.0824, which if I convert it into percentage, it is 8.24 percentage. Now the last part, that is effective interest rate if the nominal interest rate is compounded semi-annually. So I will now determine what is the effective interest rate if the given nominal interest rate is compounded semi-annually. Now for this, the value of M will be, so semi-annually is nothing but half yearly. So we'll calculate the value of M will be 2. So half yearly means there are 2 half years in a year. Therefore, I effective is equal to 1 plus 0.08 divided by 2 to the power of 2 minus 1. If you solve this, you are going to get the effective interest rate to be equal to 0.0816. This is in decimals. Again, if I convert it into percentage, it is 8.16%. So how do you convert the decimal into percentage? You just have to multiply it by 100. You are going to get it in terms of percentage. Now we'll solve one more problem on effective and nominal interest rate. A person invests a sum of rupees 35,500 in a bank at a nominal interest rate of 10% for 10 years, which is compounding quarterly. Find the maturity amount of the deposit after 10 years. Now in this question, a person is investing rupees 35,500 in a bank which is giving him 10% nominal interest rate, and this nominal interest rate is compounding quarterly, that is once in 3 months or 4 times a year. This nominal interest rate is compounding. Now we are supposed to determine what will be the maturity amount of this particular investment after 10 years. So we'll look into the solution now. Solution: given data. So they have given the investment sum of 35,500. So this I can either consider it as the principal amount or present value, because the person is investing now. If I can take either principal amount or the present value, anything is fine. So principal amount, which is denoted as capital P. Even the present value or the present worth is also capital P. So anything we can consider in this particular question, which is equal to rupees 35,500. Next, the number of interest period, which is small n, is equal to 10 years. Next, interest rate. So here it is nominal interest rate. If I'll write it as nominal interest rate, which is I nominal is equal to 10%. Compounded compounded quarterly. So this is important. Next, number of interest period. Number of interest period in a year. Which is the value of m is equal to, since it is compounded quarterly, the value of m will be 4, because 4 quarters in a year. So here first what we are supposed to do is we need to convert the nominal interest rate into effective interest rate, because in all the problems we should always consider the effective interest rate. Again, if they do not mention about anything called nominal interest rate in a question, then it is always effective interest rate what they have given. So you need not take the value of m, conversion and all is not required. If they do not mention the interest to be nominal interest rate, then you are supposed to consider it as an effective interest rate only. So here they have mentioned it as nominal interest rate, therefore we'll convert this into effective interest rate. Now effective interest rate which is IEFF is equal to, the equation what we have is 1 plus I nominal divided by m whole to the power of m minus 1. Now I'll calculate what is the I effective value. I effective is equal to 1 plus I nominal is 10%. I'll convert this into decimal, which is 0.1. 10 divided by 100 divided by m value is 4, bracket closed, whole to the power of 4 minus 1. Now if I solve this, I'm going to get this particular value as 0.1038, which is equal to 10.38%. So this is the effective interest rate if I convert the nominal interest rate of 10%, which is compounded quarterly. I'll get an effective interest rate of 10.38%. Now the second part, which is the important part which we need to calculate, we are supposed to determine the maturity amount of the deposit. Now for this I'll draw the cash flow diagram now. So as usual, you have a timeline, then you have the cash outflow, then you have the cash inflow. So it is for 10 years, so I'll just show it like this, starting with 0. Okay. Now the person is investing a sum of 35,000 in a bank. So from the person's account, the money is being transferred to the bank account, that is the cash outflow. So at time t equal to 0, he is investing, that is the value of P, which is rupees 35,500. He is now supposed to determine how much he is going to receive back for his investment after 10 years. So money will be coming into the person's account after 10 years. Therefore, it is the cash inflow. So this is the future value which we need to determine. So this particular condition is, we have to calculate the single payment compounded amount. For the single payment, what is the compounded amount? So we have the equation, the maturity value after 10 years, that is the value of F is equal to P into 1 plus I. Here we won't be considering the nominal interest rate, it is always the effective interest rate. As I told you, In all the problems, the value of I is effective interest rate only. So in the question, if they don't mention about nominal interest rate, then it is effective interest rate only. So here I will consider it as I effective to the power of n. So F is equal to P is the principal amount or the present worth, which is 35,500 multiplied by 1 plus I effective. So this will be in decimals, not in percentage. So I effective is 0.1038. So 0.1038 to the power of n. So what is the n value? That is the interest period, which is 10. So if I solve this, I am going to get the value as rupees 95,308.64. So this is the solution. If a person invests a sum of 35,500 to a bank which is giving him a nominal interest rate of 10%, which will be compounded and quarterly for 10 years, then the sum what the man is going to get after 10 years will be rupees 95,308.64.